If you go out and ask a bunch of people, what's your favorite music streaming service, you'll end up with raw data that looks like this. Now, raw data in and of itself is not that useful to us because staring at raw data, it's hard to tell things like what's the most popular music streaming service. So once we have raw data, it's important that we have some way to organize it to make it more useful. So today we're going to talk about types of tables and graphs that we can make for qualitative data. Here's our raw data, and this is qualitative data. Remember, qualitative data are usually words, and that's exactly what I have here. Apple, Apple, title, Spotify, words. The first thing I'm going to do to organize my data is make what is called a distribution. And distribution is just a fancy way of saying make a table. And the first thing I need to do is list out all the possible data values that's in my data set. So if I look at my data set, I see some apples, title, Spotify, what else? Pandora, other, anything else. I think that's all. So my possible data values are Apple, title, Spotify, Pandora, and other. Let me title this column. So Apple, title, Spotify, Pandora, other. What are these? These are all music streaming services. And the first thing we want to calculate is the frequency. Frequency just means how many. So we're just going to count how many apples there are in our data set. So in the lab, we're actually going to use R to count for us. So we're not going to count by hand. So let me actually just tell you what the frequencies are. If you were to go through and count all the apples, you should see that there are 12 apples. There are 6 titles, 16 Spotifys, 9 Pandoras, and 2 others. And that's the frequency. And the interpretation of the frequency is we're counting how many. So this 12 means that there's 12 people who said Apple was their favorite. There's 6 people who said title was their favorite. Now, we know the 12 means that there's 12 people who said Apple was their favorite. Now, the question is that we often will ask is what percent is this? So what percent said Apple was their favorite? And that's called a relative frequency. How do we calculate the relative frequency? The first thing we need is the total number of people in our sample. So how many people total in our sample? One way to do that, and a long way, is just to count 1, 2, 3, 4, 5, 6, 7, 8, and so on. Don't do that because we have the frequencies. So the 12 means that there's 12 people who liked Apple, 6 people who liked Tidal, 16 people who liked Spotify. So if you add up all the frequencies, that should give you the total number of people in our sample. And that's what we'll do. You can use any calculator to add this up. The calculator I recommend is called the Desmos Scientific Calculator. It looks like this. I'll include a link to this in the lab. So let's add up our frequencies. 12 plus 6 plus 16 plus 9 plus 2. 45. There's 45 people total in our sample. And now, to find the relative frequencies, you're just going to take the frequency and divide it by the total number of people. So 12 divided by 45. Most of the time, you'll get a long decimal. We'll agree in this class to round to 3 decimal places. Now, after this class, in the real world, you probably want to keep longer decimals to be more accurate. But for this class, we'll agree to round everything to 3 decimal places. So rounded to 3 decimal places, this will be 0.267. Next up, 6 divided by the total. 6 divided by 45. Round it to 3 decimal places. This is 0.1 133. 16 divided by the total number of people, so 16 divided by 45. Rounded to 3 decimal places, this is 0.356. Next up, 9 divided by the total, so 9 divided by 45, 0.2. This is a decimal that ended, so we didn't have to round here. And then finally, 2 divided by the total, so 2 divided by 45. Rounded to 3 decimal places, this is 0.044. Now, anytime you end up with a decimal that ends and you didn't have to round, I recommend filling in the end with zeros so that everything has 3 decimal places. And the reason why I say this is because oftentimes we'll need to compare these numbers, right? If I ask you which one is bigger, 0.133 or 0.2, what would you say? So if I didn't add zeros to the end, you might mistakenly say, well, 2 is smaller than 133, so 0.2 is smaller, and 0.133 is bigger. And you would actually be wrong, because 0.2 really means 0.200. So now, if you compare, you're comparing 200 versus 133. So 200 versus 133. 200 is bigger. So 0.2 is really bigger than 0.133. So if you end up with decimals that you didn't have to round, my recommendation is add on zeros to the end so that everything has 3 decimal places. It will make it easier to compare. Now, what is this relative frequency? So relative frequency is basically the percent. So right now it doesn't look like percents because right now they're decimals, but we can always convert it to percents. And how do we convert to percents? .267 converted to a percent. So the way you convert to a percent is multiplied by 100, which is the same thing as moving the decimal point 2 to the right. So if I move this decimal point 2 to the right, I get 26.7. So 0.267 means 26.7%. So what we're saying here is that 26.7% said Apple was their favorite. 0.200 as a percent. So move the decimal 2 to the right, you get 20.0. So 20.0% said Pandora was their favorite. The main type of graph for qualitative data is the bar plot. To make a bar plot, on the x-axis at the bottom here, I'm going to list out all the possible data values. These. So Apple, Tidal, Spotify, Pandora, other. And then I'm also going to title this. So Apple, Tidal, Spotify, what are these? These are all music streaming services. This is called a frequency bar plot. So that's telling me I should put frequency on the y-axis. Let's take a look at the frequency. The frequencies 12, 6, 16, 9, 2. So it doesn't matter how you number the y-axis. You can go by 1s, you can go by 2s, by 5s, by 10s, as long as you get up to whatever the highest is. So I need to go all the way up to 16. Let me count by 5s. 5, 10, 15, 20. Now, for each of these streaming services, we're going to make a bar. Apple has frequency 12. We're going to make a bar of height 12. Tidal was 6, so bar of height 6. Spotify, 16. Pandora, 9. Other was 2. Now, one more thing that I'll do is, right now, it's a little hard for the reader to read the height, right? So this bar for Apple is somewhere between 10 and 15, but exactly how high is it? So what I'll do is I'll label each bar with the frequency. So Apple was 12, Tidal 6, Spotify 16, Pandora 9, and other was 2. Okay, now the reader can see that Pandora is exactly 9 high. Now notice that there are gaps between the bars. You should have gaps. So for qualitative data, bar plots, you should have gaps. So this is going to distinguish it with another bar type of graph that we'll talk about in the next lecture for quantitative data. So for quantitative data, we're going to do histograms, which is another bar type graph. For quantitative data, that graph, the bars are going to touch, so there's no gaps. For qualitative data, bar plots, you should have gaps. The next variation of a bar plot is called a relative frequency bar plot. And it's basically exactly the same, except instead of frequency on the y-axis, we'll put relative frequency on the y-axis. Everything else is going to be the same. So we'll put relative frequency on the y-axis. At the bottom, it'll be the same. So Apple. Now, let's look at our relative frequencies. Our relative frequencies are these decimals, okay? My recommendation for labeling our y-axis is just to do 0.100, 0.200, 0.300, 0.400, and let's see, I need to go all the way up to 356. So I think I'm good with the 0.400. And now same thing, bars for each of these streaming services. Apple is 0.267, so that's somewhere between 200 and 300. Tidal, 0.133, somewhere between 100 and 200. Spotify, 356, that's up here. Pandora, 0.200, that's exactly right here. So that's another reason why you should add on zeros. So 0.2, if you didn't have zeros, you might mistakenly think that that's 2 and put it way down here. But 0.2 is really 0.200, so it should be up here at the 0.200. Other, 0.044, so 44, that should be below the 100. And then, just like before, I'm going to label each bar with the actual relative frequency to make it easier on my reader to read. So Apple was supposed to be 0.267, Tidal 0.133, Spotify 0.356, Pandora 0.200, and other 0.044. Okay, once again, remember, there are gaps between the bars. Write a sentence interpreting the third bar on a bar plot. So third bar on the bar plot, we're talking about this number and this number. So the 16 and 0.356. So we're basically interpreting the 16 and the 0.356. Now here's the type of sentences I want you to write. So this 16, what does that mean? So that means that there are 16 people who said Spotify was their favorite. That's the sentence I want you to write. Spotify was their favorite. Okay, so key things I'm looking for is 16, okay? 16 people. What's special about these 16 people? These 16 people said Spotify was their favorite. Now, to interpret the relative frequency, anytime you're interpreting the relative frequency, I want you to convert it to a percent. So 0.356 as a percent, move the decimal 2 to the right, that's 35.6%. So 35.6% of the people. And what's special about these 35.6%? They said Spotify was their favorite. So 35.6% of the people said Spotify was their favorite. So anytime you're interpreting a relative frequency, I want you to convert it to a percent and then tell me what's special about these 35.6%. They said Spotify was their favorite. Another type of graph that we can make with qualitative data is the pie chart. Here's an example of a pie chart. Notice that the pie chart is showing 26.7%, 30.3%, 35.6%, which is the percents that we talked about on the front page, which is essentially the relative frequency. So a pie chart is really displaying the relative frequency. And the higher the percent, the bigger the slice of the pie. And what I want to point out is that if you add up the percents, what should you get? If you add up all the percents, you should get the whole pie. What percent is the whole pie? 100%. So if you add up all the percents in a pie chart, you should get 100%. If you add up all the relative frequencies, which is the decimals version of a percent, you should get the decimal version of 100%, which is 1. So if you add up all the relative frequencies, you should get 1. Now, in practice, you might not get exactly 1 just because we're rounding here. But you still should get something close to 1. Now, what is wrong with these pie charts? What do you get when you add up the percents? You don't get 1. That's why they're bad. Don't do that. All right, that's it for today. Have a great day. Talk to you guys later.